We'll practice analyzing forces in a system of two masses connected by a cord over a pulley. Here's the problem. Two masses hang from a light cord over a frictionless pulley. Mass 1 is 6.0 kilograms, and mass 2 is 4.0 kilograms. Part A. Predict the acceleration of the system. Part B. Find the tension in the cord. First, find the net force on the system. The heavier side falls, so the net force is the difference in weights. F net equals m1 minus m2 times g, which is 6.0 minus 4.0 times 9.8, giving 19.6 newtons. Now find the acceleration using Newton's second law for the whole system. Acceleration equals F net divided by total mass, 19.6 divided by 10.0, which is 1.96 meters per second squared. Next, find the tension. Consider the lighter rising mass, T minus m2g equals m2a. T equals m2 times g plus a, which is 4.0 times 9.8 plus 1.96, giving 4.0 times 11.76, which is 47 newtons. Check using the heavier mass. T equals m1 times g minus a. T equals 6.0 times 9.8 minus 1.96, which is 6.0 times 7.84, also 47 newtons. It checks. The answer, acceleration is 2.0 meters per second squared, and tension is 47 newtons. For an Atwood machine, the acceleration is the net weight divided by total mass, and tension can be found from either mass using Newton's second law,